I welcome you back to the session on software architecture of style. This is a bit a big session consisting of 78 slides, but I'll be only letting you know the crux for every architectural style. So, as we have seen in the previous presentation, component and connectors, uh, these are been widely been used for the architectural style denotation purpose. So, component handles a particular kind of an functionality, whereas the connector is being used for having the relationships between the components. So the same things, the components is the principal processing units and the data stores. A component has a set of ports through which it interacts with the component. So port is one of the significant concept. In UML component diagrams, you can visit to the ports so that the communication can be enabled between several components altogether. So the interactions can be worked out with either attachments or interface delegation. Likewise, there could be a structure that can be applied for even interfaces also. So therefore, you can look at the constraints marked in red lines. That is, components can be attached only to connectors, not directly to the components. Connectors can be attached only to the components, not to other connectors. So these are the basic rules and principles for the keeping the communication of high quality. Now, what it is for, showing how the system works, guiding the development and helping the architecting community. Now, this is the proven technique. The architectural style is a proven technique which has been used in past. So, we will be visiting them, and typically we can construct a new architectural style altogether of our own choice, which is called as hybrid architectural style. Proceeding next, components. We all know that it is a functional unit, smallest unit again. It has got interfaces called as ports. So port is a medium of communication through which the communication can take place. A component may have many ports of the same type. So therefore, what you want to convey through the ports is very important so that the distinction between the internal and external ports should be strictly structured and strictly mentioned. With the last point you can visualize this, that is internal and external ports. External ports are been there for communicating in between the components, and within the components you can use the internal ports. So components again, they are the architectural entities. They work out with the functionality and data in encapsulated terminology. Restricted accesses. Okay, so how much, up to what extent you can expose the component, that will depend on the type of cohesion and coupling you want to achieve. Ideally, it is impossible to achieve high cohesion and low coupling. So practically infeasible things we are not taking into account. So there will be a medium to high kind of an cohesion and low to medium kind of an coupling that we can afford. Connectors which determine the interaction patterns, and remember that interaction patterns, if we are seeing, they should not be associated with the processing jobs, because processing jobs has to be done by the components, and these components demonstrate these functionalities by a set of services. Now services are the things that are been indicating that a component is suggesting these are the things that I can do for you. Okay, that is for other components. So the services should be visible, but the responsibilities many of the times they are being hidden. Going next, connections, they are there as in patterns of interaction, and you can have the roles which are associated. Now a connector can have invokes services or provides services. That is, either donates the services or receives the services, sends the services or receives the services, right? So it is an what you can say, listener mode is always been preferable whenever you want to invoke, that is who is been providing this particular service. You have to contact to right kind of an component for right kind of an services, and just see to it that, for example, a pipe can have writer and reader rules. Again, to remind you, pipe is being used as a communication channel, and the computational jobs are being kept with the filter. So another example is the publish subscribe connection. They can have multiple instances of publishers and subscriber rules, because you cannot subscribe just many things from a single publisher, or many publisher cannot target a single subscriber. Now, a rule defines the expectations of the participant in an interaction. Now, what does this mean? Expectations of a participant. So, therefore, service invoker initializes the connection. Service invoker initializes the connection, ensures that the connection is being set up, and then the taking up the right kind of an contents down to itself, right? So connection establishment, then porting down the information that has been required either in terms of services or units of services, that is data or commands or code fragments if they are being shared. Next is the typical kind of an component connector types advises that the components should share the same form and behavior, and they should have the same kind of an vocabulary. So one component is saying something else, the another component is saying the same thing in some different kind of an vocabulary is not acceptable. So application specific types covers all of the components. The definition of the component or connector type should explain in general the information about the computational nature. Enough guidance has to be provided, and it should characterize the number and types of interfaces. Now, just see to it the number of interfaces, why they are being important. If the computations are being ongoing, and if you are using multiple, let us say interface is 10 raised to 3, and you have got 100 components only. So this is an indicator of high coupling, and probably that we will not wish to have. So therefore, the resizing the interfaces, having just the needed interfaces is also one of the important criteria, because you will not wish to have all of the interfaces present and components are being absent. Only 5 components are there and there are dozens of interfaces, right? So this situation has to be avoided. So these are the properties. Typically they are been dealing with NFRs except the functionality. Now let us take up the last point, that is tire, because the rest of all the points have been addressed in the previous communication to you. That is tire. For tire topology, what tire does a component reside in? This property helps to define and build the deployment feature. Tire is of course something which is different from layer. One layer can consist of different tires altogether, but one tire cannot consist of different layers altogether inside it, isn't it? Likewise, for railway bogies, you must have observed whether it is 2 tire, 3 tire, right? So this tires terminology is about one single layer, how many tires that can be accommodated. Next is implemented versus conceptual connectors, right? So this is something to deal with again, how to avoid dedicated code without any identity. Then working around on connector is not equal to component, they are different. So the associations could be binary, that is 1:2, or n-ary, that is 1 to 1, 1 to many, many to many. Many to 1 is with discarded kind of a relationship, because duplication is not allowed, because association is bidirectional by default. Asymmetric versus symmetric kind of a structure and interaction protocols. Now look at the benefits. Separate computation from interaction. That is what is our requirement is. Minimize the component interdependencies, that is achieve low coupling as far as possible. Support software potential for supporting dynamism, that is address the concurrency issues. Facilitate the heterogeneity, that is state changes. Do they require to be migrated or should be kept within the components? Because unless and until the component decide to transfer the state, the other component cannot dictate the component in question to transfer the states. Right? So what we have to look for? We have to look for the localization of interaction definition, extra component system communication, component independence, that is cohesion, and component interaction flexibility. That is how many possible ways are being there for communication. Otherwise the communication becomes static. Going next, there are the rules. Just have a look at the rules only. Rules are communication, coordination, conversion, facilitation. Now, which is time consuming? If I can say, okay, ask you one question, that which is time consuming, you can suggest any of this option, right? But the correct choice is conversion. Conversion is typically been a difficult kind of an process. Facilitation is an higher order kind of an rule. Okay, typically that has been observed with adapters. Adapters translates the services patterns from one particular environment to another environment. Typically, we may not be working with homogeneous system environment. We might be there with the heterogeneous environments. So, there two different systems from two different environments would be communicating. So, communication mechanisms likewise RPCs and all of that we have seen. And then connectors, they could be coordinators. They can determine the computation control delivery of data, separate control from computation. This is very important, that computation should not be amalgamated with the control, that is transferring from one particular component to another component or within the component itself if you are passing the control. Connectors as converters, that is mismatches which have been based on type, number, frequency and order. It is, as I have told you, that conversion is a difficult kind of an process, and I have already commented that types of converter, one of that was adapters, another is wrappers, okay, that keeps up multiple things together, binds the multiple things together and conveys the result. Connectors as facilitators, it is a high-end job typically intended to interoperate, that is mediate and streamline. So performance profiles, synchronization mechanisms, these are all, internal details, that is matching the system environment with the component dynamics, that is load balancing or critical sections or monitors. Now many of the operating system concepts will be coming up in picture when we try to work out the connectors as facilitators. Memory will be again one of the important story. Connector types have been mentioned, okay, as a list. So now we move on to the first architectural style, that is open versus closed architecture. In closed architecture, these two are very simple to understand, but we must understand them. Closed architecture, each layer only uses the services of the immediately below level. Now layer N can refer to n minus 1 only. Layer 2 can refer to layer 1 only. So this minimizes the dependencies amongst the layers and reduces the impact of the change. But direct jumping from an layer n to layer 1 is not possible in case of closed architecture, right? So that is what is a kind of a limitation. Okay, this is in some way sequential kind of an order of processing or communicating. Open architectures, the layers can use services from any of the low layers, right? So likewise, the thing that I was mentioning, n can directly contact to layer 1. Layer n can contact to layer 1. N minus 1 can contact to layer 1. So likewise, you can have any of the layers communicating to any of the layers, right? So the resultant is more compact code, but just see to it, the biggest disappointment is that it breaks the encapsulation of layers. So increases the dependencies between the layers. So if you can afford these dependencies and if you can manage, open architectures are being used and they are being widely being used, open architectures versus closed architectures. Typically closed architectures are being there with the minimal level kind of an functionality architectures, right? So if you ask ISO OSI reference model, which goes up okay in an closed kind of an way, isn't it? But the other kind of an layered architectures, typically in case of operating systems, they communicate cross layers, right? So this is the component connector style hierarchy, generic hierarchy. Just have a quick look at this. 4 major types are there: data flow, call return, event based, and repository. Repository consists of shared data and Blackboard. Blackboard, we see that everybody can visualize, everybody can share, isn't that? One can write, erase. So controlling mechanism becomes difficult in case of Blackboard. In event based, as the event appears, then the processing will become active after that. Publish, subscribe. One thing is being published through the ports and subscribers will be getting adequate knowledge through these services, through subscriptions. Point-to-point messaging, POP in short, SOA, that is service oriented architecture. In call return style, because the communication protocol says that there are only 2 choices: request reply and request reply acknowledgement. So RR cycle and RRA cycle. So call return cycle, okay, or call return style is been based with the RRA cycle, right? So we have got client server, peer to peer, multi-tier client server, because you just cannot depend on 2-tier architecture. So it could be 3-tier, 4-tier, n-tier, etc., etc. Data flow, it is batch sequential, ancient historic kind of and stuff, batch sequential. Pipe and filter, examples of this thing is the pipeline, Unix pipe and filter. Linux is also the indicator of pipe and filter architecture. Some of the other architectures are also using pipe and filter. Data flow, just try to see to it, batch sequential thing has been there. Okay, we have done a lot of things with this data flow architecture style, that is batch sequential architectures, pipes and filters, and same processes, same machines, same network. Okay, conceptually filters consume data from input and output is being provided, and then pipe and filter. We are aware about what pipes do and what filters do. So no summarization is required here, but again to remind you, filters are doing the computational jobs, pipes are being used for communication purpose. Just see to it, okay, where it can be used. Image processing, Unix pipe shell programs, compilers, they use pipe and filter structure. Filters do not know their sources and sinks of data. Now then, filters are relieved of knowing their sources and destinations. So this is the biggest advantage, right? So just see to it that it support reuse, easy to maintain because you have got clear distinction between the communication channels and the computations. Disadvantages, it is not good, of course it is not good for interactive applications because you must know how to bind the services together, that is packing and unpacking POS, because the filters themselves they do not know, isn't it, source and sinks of data. So the question is that can I embed commands and data together and have the stream of self-executing? Yes, of course, why not? You can do that. So this is the summary, which I will not read it because the points have been clarified to you. And this is the diagram, how the things look like. Multiple filters you can observe. They are connected through pipes, and filters don't know anything about what they are connected to. Very, very important. And filters can be implemented in parallel. Of course, it is the job of the pipes, okay, to interconnect the filters all together. So, data hiding, that is internal data representations are not visible to clients. That is a good aspect of pipe and filter architectural styles. And the only thing remains is that in case of object orientation, objects must know the identity of the objects they wish to interact with. This is what is the another thing, right? So pipe and filter, pipes includes pipes capacity, that is the buffer size, how the end data is signaled, and what kind of an blocking occurs. Filters can include, as they have been communication channels, whether or not each filter is a separate process or you can reuse. Probably you might not be able to reuse, right? So computations are being controlled in some way, some sense by the pipes, because the correct arrangement will be suggested by pipes only, where the filters are not required to have the knowledge of what is being connected to it. So this is the summary of one of the architectures, DB2 architecture, where you have got clients and server, and you can see there are the buffers and pools, okay, over here. I hope so everybody can observe this, okay. Sub agents are being there, and you can have the multiple hard disks that are being connected together on the server side, and you can maintain a log buffer, and through the correct protocols, that is shared memory, semaphores, TCP IP, named pipes, IPX speeds, you can communicate with the client application. Now what happens is over here, the server is not aware that the components on the server side may not be aware about the how many clients will be there, okay, in a particular scenario. But the memory reservations can be done for accommodation of these clients. So this is one of the popular architectures which has been using pipe and filter architectural style. And just try to see to it what is the difference between layered and pipes and filters. You can see to it that there are several layers: presentation, business, service, persistence, and database. And here in this case, you can see that there is a parallelism. Use case 1, use case 2, use case 3, use case 4. They are being grouped around, okay, with the pipes and filters. And this is an example from Apache Camel, right? And it works around on this particular kind of a way, right? It provides a particular kind of a view for the end user by handling a typical kind of an use case that is in demand. Call and return, this is again an age-old style, call and return. We have used it for many of the times, isn't it? Intelligence has been there with the central host computer. Advantage is that mainframe software architectures are not tied to hardware platform. So platform specificness is not there with call return. Disadvantages is that it do not easily support GUIs. Biggest disadvantage. Because call return is considered as a kind of an internal matter of the components typically. Uh, so file sharing is another kind of an example where you try to share the files way back in 1990s where LAN was been first practically been available. So there people have used this particular uh, feature file sharing. Today also we use the file sharing. How it happens is that is from the mainframes we can replace the term mainframes by the servers that we have been using. There are several files and they are being brought up from the buffer to the application buffer so that they are being visible. So now we move around to network centered styles. So here on the discussion will be the focus on communication, right? So as we have seen loose coupling versus tight coupling, majority of the systems are working with the loose coupling, isn't it? So that avoids global data sharing kind of and disadvantages which are in there, and it works around with the separation of concerns. That is, individual concern can be addressed easily. If cross-cutting concerns are being there, then they are being grouped into separate kind of models. Just you can see to it that aspect-oriented programming separates cross-cutting concerns. I mean, overlapping, oversecting, I mean, intersecting groups can be formed and then the related functionality can be supported. The client server, okay, the biggest discussed story and what architectural style that is, it can be realized through a shared repository and you can have single centralized server or multiple distributed server. As you try to increase the complexity on the server side, naturally the availability and the portability, these two questions one has to answer. So centralized servers are easier to administer, whereas distributed servers they scale better, but would introduce complexity because they work around on two-phase commit. They do not work around on single-phase commit. So there are two types of scaling vertically, that is by increasing computing power of single machine, scaling up, that is vertically, horizontally by adding more machine, that is scale out. Typically the horizontal fashion, that is adding more machine, is being thought of as an distributed computing kind of and stuff. So just see to it before that, can you increase the computation power of a single machine, that is scaling up? If you can do that, you will not be requiring to add up more machine, that is scale out option. So in scale out option, you have to work out really very well to administer the concurrency and resolve the issues related to concurrency. Likewise, thread management, process management, working around with forks, working around with joins, isn't it? And then there are the implementations of the client server architectures. You can see there is a client, mobile client, desktop client connected to server. Then there are multiple clients which are being connected to a server. In centralized, you can have clients connected to a single server. In distributed, the clients are being connected to multiple servers through a network. But the theme, as I had discussed in the previous slide, is that centralized is easy to administer, whereas distributed is better for scaling up the solution. Okay. So, uh, this is one of the terms that is stateful and stateless servers. So, stateful versus stateless. If the client server communication is stateful, the server keeps a track of application state. Very simple to understand. Just keep the track of application state, whether it is active, inactive, or what are the activities that are been going around, monitor it, put up into the log file. In the case of stateless, you are not required to preserve this kind of data. So whatsoever application does, you need not require to monitor it. Okay? So stateful servers are being used if you are interested in working around an administration kind of an point of view, or if you are going with the distributed kind of servers. Typically, stateless approaches are being used because you cannot monitor what's going around the world. So this is the summary. One diagram showing peer-to-peer, that is a mesh type connection. Advantages is conceptually simple, but the disadvantage is that bad usability and performance. So one has to bother and think before using the client server terminology, because the protocols are being available, but for the decentralization, what are the alternatives one has to think about. So this is again the revamp of client server for your reading purpose, and client server computing, request reply, RRA I have mentioned earlier on as well. Examples have been mentioned. Okay, GUI driven, that is Visual Basic, Oracle, right? Web servers, likewise Tomcat. And now the tires analogy. I said something about the tire previously also. Now let us revise it so that there should not be a confusion between layer and a tire. Two-layered architecture and two-tire architecture. Difference is obviously there. Words doesn't matter. The execution structures of many systems are organized as a set of logical groupings of components. Logical groupings. And this grouping is been termed as tire. This grouping is been termed as tire. Multi-tire is been applicable in Java Enterprise Edition and .NET applications. So in summary, a tire is a mechanism for system partitioning, and it is applied to client server based systems where various parts of tires of the system can communicate. Now here you should not misjudge tires with the layers, right? Layers is a different issue, tire is a different issue. You have to remember the example of bogie that I have given to you, 2 tire, 3 tire, okay? Just remember that, the things will be automatically clarified. So we have got n tire architecture where we are scaling beyond 3 tire, right? N-tire architecture. So typically web applications are supporting the entire architecture. They use the entire architecture. Two-tire architecture, they are being rich in UI, application logic, and communication. Server stores the data, so client is not required to bother about the same. But one of the things is that client might not be notified about the data is being saved at the background at the server. So each client runs a complete application. Drawback, each client has to know how to communicate with all data servers. It is not the job or duty of the server to contact to the clients and ask them that yes, do you wish to communicate, okay, do you want to use, yeah. So server will not be throwing any kind of an polling kind of an stuff that you have studied in operating system, polling mechanism, polling. So polling is avoided, right? 3-tier architecture evolved from 2-tier architectures naturally. A third tier is inserted between, just see this, between the clients and data servers. Clients and data servers. So, what we see that this tier is a middle tier. So, just because the middle tier, this name is been given, middleware has came in picture, right? Middleware has came in picture. So there are also the categories, okay, for the clients, okay, thin clients, fat clients, and so and so on. So entire structures are rich client, and then they are been communicating with the data stores. Clients are communicating with the data stores, data servers, and then there is an application server. Now here you have got the 3 tiers, right? Presentation, application, and data. One of the thing that is being there is, what do we mean by rich client? The rich client has multiple services which are being made available to it, right? A lesser number of services that are being provided may be a thin kind of an client or a swift kind of an client which can have a movement. A rich client typically will not cause too much kind of an movement, right? Rich thin client, just see to it. Again, the separation is been done. A rich client contains full knowledge of application. Clients for custom applications using custom protocols. Examples is email clients. And thin clients, just see to it. Clients do not have to know the knowledge on the application. So web clients are there. They are not required to know about the application. You should not have. Even Ajax, okay, the application knowledge is there on the server, right? So that is what is the difference between the rich client and thin client. So the discussion is not just limited to client and server. We have to, of course, see into the category of clients also. So this is another example of rich clients versus thin clients. You just see that additional layers are being added for thin clients. Why so? Additional tiers, you can see that they are being added. Why so? Because the thin clients are not preserving any kind of a knowledge, right? They are not required to know. So it is the job of the server to provide the services so as to make the client knowledgeable. Next is the peer-to-peer style. Peer-to-peer. One single end has been connected to another single end. Each client is a server. At the time is called as a peer, right? The separation between client and server is removed. There is no client, there is no server. One client connected to another kind of an peer is becoming server at that time. The goal is to distribute the processing data. No central administration. We have seen central administration was also there in client server. Decentralized administration was also there. But this has been missing in peer-to-peer. So the example is bootstrapping programs, good for scalability, but what has been happening here is that very complex and very hard to maintain and test, and quality of service, QoS in short, is not deterministic or not guaranteed. So this is the summary of the peer-to-peer things. Okay, the peer-to-peer communication flow is symmetric, right? So one peer search for another peer is propagated from one peer to its connected peer for a limited number of hops. So if within those limited number of hops the things are not being identified, then the next hop will continue. Therefore, the peer-to-peer architecture may have special peer nodes, ultra peers or ultra nodes or super nodes that has got indexing to simplify the searching uh, abilities for the peer. So just remember these things, okay? Ultra peers, ultra nodes or super nodes, making the things simple for the peer to take on to the another peer and form the connection with the another peer with limited number of hops, right? So these are the properties in text. I'll be picking up only the important points from this thing. So just see to it that peers can be added or removed. Here you can see that flexibility has been there. Peers can be added or removed from the peer-to-peer network with no significant impact, because there is no tight kind of an bonding that exists. Right? Only the thing is that the management side on the peer is required, and you can have ultra nodes or super nodes, okay, guiding the peer. Right? And then suitable deployment, that is efficient use of CPU and disk resources, is required to be there. And then this is the summary of peer-to-peer style. Another summary of retailer peer request information processor, right? Then we move on to SOA, that is service oriented architecture, which has been widely used by many industries. Just see to it that it consists of distributed components that provides or consume services. We have to take on very simply, we have to have our own simple approach to understand SOA in better way. So just see to it that first up it is dealing with distributed components, distributed. Next, they provide the services or consume the services. Okay, how they are doing that? Through service providers and service consumers. Now the next thing is that what is the media? Media is been the enterprise service bus. So ESB routes the messages between the consumers and providers. So the orchestration server. Now what is the orchestration server? Before that, there is something that is service registry. Each of the service provider and the service consumer has to work out with the service registry, that I am a registered service consumer, I am a registered service provider having this kind of an services which this kind of an service consumers can use. So application server, so it is a big dictionary, right? It's a big dictionary, the service registry typically. An orchestration server, okay, how to work out with the communication. This is what is the job of orchestration server. There will be multiple services, because the name itself suggesting service oriented. Multiple services will be there. There has to be a smooth kind of an interaction pattern that should happen between the services. Therefore, there should not be any kind of an hangout time. So typically it is being administered by BPEL, Business Process Execution language. Many of the communities, industry communities, they have been using SOAs these days. So in detail, you can find out there is SLA, service level agreements. This has to be done at the beginning. For the service providers and service consumers, they can invoke the services directly or through intermediate access. ESB we have discussed, orchestration server we have discussed. SOAP connector, they may be using SOAP protocol, or they may keep a dialog usually over HTTP, and REST connector, right? So moving around to the service invocation, the thing that happens is that invocation means a call has been given and the request has been resolved. Can be there with the three things, that is dependability, security and performance. That whether right kind of a session is been taking place. right kind of a session has been taking place. We are speaking about consumption of service and release of the service. Unless and until the services are being released, none of the clients, okay, on the other side can of the service consumers can consume the service. So how the errors are being handled also, that is an interesting issue in this particular scenario. SOA example, just see to it, there is a bank transaction authorizer, ATM monitoring service, reconfiguration server, and then you can have the communications which are being made through between the clients and server. So the basis for the SOA is client server, but with amendments. This is another example, that is bank, airline provider, lodging provider. All of the things are being available with this single kind of an unit, right? Through the web browser, you can search anything. Typically, online purchases and cloud computing, they are being using SOAs, ESBs very widely. Now the broker architecture. This is something different, broker architecture. Now broker knows to whom to be contacted. Broker knows. Okay, the clients do not know, but the broker knows whom to be contacted. So the broker system was being used way back in the middleware. Typically, it is a section of middleware, broker-oriented architectures. The broker can be implemented as a separate layer, and that is what is middle layer I am talking about. Advantages are decoupling of components, allows the system to be distributed. Disadvantage is that the communication might introduce new types of errors. Now, Inceptor, this is another kind of thing which works around with the open-closed principle. Open-closed, open for extension, but closed for modification. So, end-to-end modification is being muted, right? The system consists of only two components, a client and a server. So, Inceptor is a very initial or beginner's level kind of a client server architecture. So it works around on loose coupling. That is what is the benefit. Disadvantage, it can get complex quickly. Okay, as the number of clients increases, the pressure will be there on the loops, which might become endless, and there could be cascaded fallbacks. So broker examples are been there. Okay, you can see the broker has been there here. Broker layer, clients are there. They are connected through the network, and it is the job of the broker to take up the client with the right kind of a possible solution. Inceptors, we have got logging components for both the client and server. Once they are logged in, the client can communicate with the server. Event-based architecture styles, one of the important and widely used event, that is something happens in a real world scenario, either being initiated by the user or happens as an internal processing of the system. So components here, okay, as a disadvantage, relinquish control over the computation performed by the system. So the components have to be connected in an order, okay, because the components themselves do not know in which order the events will be processed. Likewise, we don't know what is going to happen next, okay, within 1 hour with us. The same way, the component doesn't know about what kind of an events that are going to happen, because such a prediction system is not been available. So always the components should be in a listener's mode, that am I getting been informed, right? So event-based architectures, okay, the example of that is the Genie architecture, provided with the event specification by services. and event registration by clients and services, and they are being there with the event timestamps, that is within a definite kind of a time frame. The event has to furnish the kind of a result, right, backwards to the clients, right. So this is another example. Now here we can clearly identify the event comes in. Very carefully have a look at this. Event comes in. It has been there into the event queue. There is event mediator, and through various event channels we can now disseminate these events to the event processors, and event processors are consisting of modules, and modules are consisting of components. Again, to repeat up the flow, events they are been coming in, they are been there logged into the event queue, given to event mediators, which will cross-check the uh, dependencies, and then through the event channel, the communication has been set up. So this is how event-based architecture style works out. So interpreter is an usual kind of an style. Okay, typically you have used the interpreter. Example of that is SQL. You have used it, right? And programming languages that provides virtual machine concepts, that is Pascal, Java, Basic, isn't it? They are all using interpreters style. So another thing is the rule based system. You have got the rule interpreter. Typically this is the part and parcel of expert systems, where you are having the knowledge base and only you have to indicate the code. So just for a matter of comparison, if you are writing a 300 line code in C, and the same thing you want to do with Prolog, which supports the expert systems development, and you will be requiring only nearly 10-15 lines of code in Prolog. So you can compare, isn't it? And also you can apply the value of the interpreters, isn't it? Likewise C is being used as the structural and procedural language. And then if you are writing 300 lines code again, you can use a single command queries and a DML query supporting that. So this is another detailed kind of an diagram which suggests the rule based style, right? And basic section is been mentioned over here. Likewise, you have got working memory, rule interpreter has been there, rules are been set up, and then you work around with the rule and fact compiler, and then meta control rules. That is, you have to have certain information about the rules themselves, how they can be written, and then the rule based system can be deployed. So fair enough complexity has been there in rule based architectural style. So specific domains are being targeted in the rule based systems. Notification architectures, this is something new. Notification, publish and subscribe, listener and callbacks observer patterns. This has been the another comparative kind of an measures. Publisher and subscribers are the two entities, and just see to it, execution labels. Components are interested in events registered directly with a process. Components register with a dedicated notification component, right, on a request, right. So you can broadcast, or otherwise you can have a separate push-pull cycle for yourself in case of notification architecture, publish and subscribe. Similar to notification architectures, we can have the message queues. You can have publish subscribes or point-to-point publish subscribes. The disadvantages, just see to it, okay, no control over process flow. the performance may be hampered due to asynchronous nature, because whenever you are having asynchronous flow, you are waiting for RRA cycle, isn't it, to happen. And just to see to it that here two diagrams are being drawn. A, B, C are being trying to communicate with the X. Now X is using a medium called N, through which the things can be channelized, that is through ABC. These are the another kind of a set of details which you can read and understand. MVC is a very popular pattern that you will find in industry, that they are using model view controller pattern. This is the summary of publish subscribe style. This is again the summary. One of the thing is, just see to it that user code fragments are associated with predefined events such as mouse clicks. We are being dependent on the mouse clicks, okay, very often, okay. Or if we are using web apps, our taps, isn't it, will indicate that we are interested in certain thing. It also permits the heterogeneous mix of components that has got implicit, means not conveyed explicitly, implicit invocations, right? So both the things are being supported, and here the query is that the which events a component announces or subscribes to. That is, announcer is being blocked due to what? And then new publishers, how they can be added dynamically. How we can maintain the subscriber queue up. So somewhere event queue you have seen, somewhere like that can we maintain a subscriber queue and a subscriber channel? Can we do like that? This is an question, right? So what is the semantics of each event? That is, how to recognize the event and what requests are being there with that particular event, okay, whether they are being known or unknown. This is merely an example of this subscribe view. Shared data style is an elementary data style where the things are being kept right at the center. A buffet system is an example of shared data style, right? Rest of the things can be read and understood. This is another example of enterprise access management thing. Once you do the authorization through the password, you can do multiple things, okay, with the shared. Now the cross-cutting issues are what are the process alternatives? What are the things that if I will be distributing the terminologies, isn't it? What if I want to address the concurrency? What if I would be using the threads and processes? And how to deal with the communicating processes, that is preemptions. Always you cannot preempt, that is what is the possibility. Timing parameters, what should be there, shared resources now, and deadlock prevention. Now here you will recognize the importance of the subject that you studied back, that is operating system, that many things without the knowledge of operating system are not understandable. Watchdog timers and schedulers, okay, is coming from the hardware theory. And how we can look into the dynamic aspects of the architecture. Okay, can we make the architecture dynamic? Now dynamic means at the runtime. Can we create, manage or destroy the elements? Because you can't keep everything alive at runtime. Blackboard style, it is a very elementary kind of a style. Explained to you previously also. You have got the knowledge source, Blackboard data structure, and there is a minimal control that is being offered, okay, that who can write, who can read, okay, for how many clients you can read, you can perform, right. So the knowledge section consists of the conditions and sections and bodies, and then you have got a controller and you have got the data units. Okay, here the Blackboard layers are being shared. Likewise, one group, one student group decides to narrate, okay, on one particular part. Another part is being written by some another group. So this kind of an principle works in here with the Blackboard layers. The repository, we have already been visited to repository architecture. So knowledge source, isn't it, has to be represented very clearly, and there has to be a common interaction language that should be followed. So Blackboards, we have seen each knowledge source knows its triggering conditions and activations. Without that, one cannot work out with the Blackboard model, otherwise things will be hidden. Blackboard is a global structure. Just see to it. Okay, the difficulty is that this is highly dependent on coupling, very high level of coupling. Okay, so triggering mechanisms are playing a very crucial role. Who will become active? Because if all of the knowledge resources, okay, are becoming active, probably the memory will be flooded and nothing will be working. Okay, it will be, the system moves into a tri-state. That experience will be there, and just see to it. Only with the kind of an elementary kind of a thing, the Blackboard style is being used. That is sensory interpretation, design and layout, process control, computer vision, data fusion, right? And it has got certain advantages, okay, about the task allocation policies, load redistributions, and just see to it that Blackboard is not the best kind of an solution, because it poses up the question of how you are going to manage the states, isn't it? And that is not an easy question to answer, right? So, as I have told you, that the important kind of an architectural pattern that is being used by industry is the MVC, that is Model View Controller. Model encapsulates the behavior and data of application domain, whereas the view renders the model for the presentation. See the difference between model and view. Model encapsulates the behavior and data, whereas view renders the model for presentation. Controller reacts on the user interface. So the jobs are very clearly defined. Okay, it's been used by many of the web apps. Okay, that is Java Server Faces, JSF, Struts, Django, Ruby on Rails, and so on. So MVC, again to repeat, model encapsulating behavior and data, like what an object was been doing, encapsulating data and function. Similarly, data and behavior. View renders the model for presentation to the outside world. Now, who will do the reactive kind of stuff? It is been based on the controller. So controller triggers up the model, modifies the model, dispatches to the view, and then the reliable view can be rendered for presentation to the outside world. So I hope so that you must have understood that these three terms very clearly. Model, just see to it, responds to the state queries, exposes application functionality, and then the view renders the model, that is request updates from the model, and the controller defines the behavior manipulating the model selects view for the response. Now the relationship is that the MVC does not replace the entire architecture. This is not at all similar or same to the entire architecture. It is model is the part of entire pattern and the MVC pattern. This is the right kind of stuff that we can understand. So the model communicates with the lower abstraction layers because it is important to have these abstraction layers and the notification patterns so that the correct kind of an model can correctly represent the view to the outside world, right, through the controller. Distributed architectures might not be used in that particular detail. Share nothing architecture, no centralized data storage, okay. Sharing or sharding, you can say that split the data horizontally, isn't it? And let the each node process the pages, process the shards, isn't it? And then combine it into a single result. So remember the term sharding, isn't it? When you are speaking about distributed architecture, right, where the client has to do, and it is the beginning of 1980s, popularized by Google again, isn't it? Then heterogeneous systems and heterogeneous architectures, they focus on the real world. No real system follows strictly only on a single system. Just see to it that entire architectures are layered architectures. They are data-centric architectures, and architectures might be structurally heterogeneous, and the single component follow other styles. Likewise, the web has two-tier architecture, and then the browser itself has a notification, and then we can see to it that it is not that easy to work around on heterogeneous architectures, because you are trying to combine the architecture styles here. So that may not be that much easy to work around with the uh, architectures. Google search engine, your topic of interest, Google search engine that we use typically. You have got the conceptual layers, you have got structural layer, that is notification architectures, you have got crawlers, you have got your servers, store servers, and in between, just see to it, okay, let us take one by one. Okay, you have got the server side kind of stories, store server, crawler, URL servers, and in between you have got the repository which has the server side information. Anchors, you have the URL resolver, indexers which are working around management, okay, and sorts or kind of an indexing that is being provided so that we can work out with quick kind of an information search, and these searches are being strictly based on what information we want to convey to the end user. So the mechanism is widely, you can see to it that once again visiting to the heterogeneous architectures, just see to it that entire architectures are layered. So layered architectures, the tiered architectures, the concept of rich and thin clients, the concept of state transfers, the statefulness, the statelessness, the service commitments, service resolutions, and this all stories are been the important issues in architectural style selection. So you cannot blindly select any of the architectural style because you have used it in the past, and because you are being fanatic about a particular architectural style. One more thing to remember that architecture is implementation independent, and it is the design which suggests about the implementation details.